Hello dear students, welcome to brilliantmaths.com, where every student has an opportunity to learn and excel in maths. Have you subscribed? Please do subscribe to brilliantmaths.com. You have lots and lots of resources available to you. Today's lesson is actually taken from Brilliant Maths Module 4. We're going to be looking at circles. Let's go for the lesson. In this lesson, we want to learn how to calculate the circumference and the area of a circle. But what do we mean by circumference? The perimeter of a circle is the circumference of the circle because that's the distance around the circle. The total distance around the circle is the perimeter, and that is what is called the circumference. And the formula for finding the circumference of a circle is pi times diameter. Pi is a constant, which is about 3.142 or 22/7. Pi times diameter will give you the circumference of a circle. And we know that the diameter is equal to 2 times the radius, because the radius is half of the diameter. So you either use pi diameter or 2 pi r, since 2r is d. So if you are finding the circumference of a semicircle is half of a circle. So it will be half 2 pi r. The 2 will cancel out, so it will be pi r. Or if you are using the diameter, it will be pi diameter divided by 2. If you have the quarter of a circle, then you apply the same principle. It will be 1/4 of pi d or 1/4 of 2 pi r, and that will give you half pi r. That will be half the circumference of a semicircle. It's good for you to understand so that you really be able to solve the problems easily. The area of a circle is calculated by multiplying the constant pi by radius squared. So that's pi r squared. So if you have a semicircle, it will be half of that. If you have the quarter of a circle, it will be 1/4 pi r squared. And in example 1, calculate the circumference and the area of a circle of diameter 12 centimeters. So we have a circle, and the diameter of the circle is 12 centimeters, and we want to find the circumference and the area. Using the formulas we've learned already, circumference is equal to 2 pi r or pi diameter. I'll choose to use 2 pi r. So if the diameter is 12 centimeters, then the radius is 12 centimeters divided by 2, which is equal to 6 centimeters. The circumference would then be 2 times pi times 6 centimeters, and that will give you 37.7 centimeters. Put that into your calculator, you'll see that it's correct. And note that circumference, the distance around the shape, is a linear measure. So it is in centimeters in this case. So the area of the circle will be pi r squared. And r, the radius, is 6, like we said before, half of the diameter. So we have pi times 6 times 6, or pi times 6 squared, which is 36. And pi times 6 squared will give us 113.1 squared centimeters, which is approximately 113 centimeter squared. Its area, so, is in squared units, because you have 2 dimensions. The radius is multiplying itself twice. It will be good for you to know when you have a linear measure, when you have an area measure, or the measure of capacity or volume, where the units are cubed. Let's look at another example. Looking at more examples on area and circumference. Looking at more examples on calculating the circumference and area of circles or solving problems with circles, we have another example. The area of a circle is 34 centimeters squared. So we've been given the area. Calculate the radius, giving your answer to 2 decimal places. So in this question, you've been given the area, And we know that the formula for the area of a circle is area is equal to pi r squared. So we input what we have into the formula. 34, which is area, is equal to pi r squared. We are looking for the value of the radius. So make r the subject, make radius the subject, so we can find the radius. So we divide area by pi and then find the square root to take off the r squared, so that r is equal to the square root of the area divided by pi. We input the figures. R is equal to the square root of 34 over the value of pi, which is 3.142. If you put that in your calculator, you will find that r, which is the radius, is approximately 3.29 centimeters. So the radius is 3.29 centimeters to 2 decimal places. If it was to 1 decimal place, it would be 3.3. In the next example, find the area of the shaded portion of the figure below. We have 2 circles. They are concentric. One is in the other. There's a smaller circle and a bigger one. The radius of the small circle is 7 centimeters, and the radius of the bigger circle is 14 centimeters. So you find the area of the larger one, and then find the area of the smaller circle, and find the difference. That's the area of the shaded portion. Most times when you have shaded portions, it's very easy to find, because you just find the areas outside the borders and inside, and then you find the difference. So here, area of larger circle is pi times radius squared. The radius is 14. So pi times 14 centimeters times 14 centimeters, and that gives us 615.8 centimeter squared. The second one, which is the smaller circle now, is pi times 7 centimeters times 7 centimeters, and that gives us 153.99 centimeter squared. Then we round them to the nearest whole number. So 615.8 becomes 616, and 153.99 becomes 154. Both of them rounded to the nearest whole number. Then we find the difference, and the difference is 462 centimeter squared. So the area of this shaded portion is 462 centimeters squared. Go over it again. You will find out that it's easy. And get more examples from Brilliant Maths Module 4. In this part of the lesson, we want to learn how to calculate arc length and sector area. But let's understand what we mean by arc length and sector. If you have a circle, the line from the center to the circumference is a radius. We already learned that. So when you have 2 radii, the section between the 2 radii is called a sector. So this is a minor sector, and then the major sector is the other part of the circle. There's an angle between the 2 radii. So let's call that angle theta. Remember that the circumference of a circle, that's the distance around the circle, or the perimeter of the circle, is 2 pi r. Then, the angle at the center is a fraction of the total angle at the center of the circle, which is a complete revolution, and which is equal to 360 degrees. So, the arc length of this sector is a fraction of the circumference of the circle. So from the formula, arc length is equal to theta over 360 times 2 pi r. 2 pi r is the circumference of the entire circle. So theta over 360 will give you that fraction of the angle that is enclosed in the sector. That's very interesting, and I would like you to take note of that. In the same way, the area of a sector is theta over 360 times pi r squared. Pi r squared is the area of the entire circle. So to find the area of the sector, you use the angle at the center, which is a fraction of 360, and multiply that by the area of the circle to find the area of the sector. So assuming you were given this information and given theta and told to find the area of the major sector, that means you'll be subtracting the angle from the minor sector to subtract that from 360, and then use that as your theta to find the area of the major sector. So this is the minor arc, and the rest of it is a major arc. And then the inner small sector here is a minor sector, and then the rest of it is a major sector. I just hope you understand. Let's look at this example. Find the following: arc length, sector area or area of the sector, and the perimeter of the sector above. This is a sector. It's like cutting out that piece and then taking it out. So in this case, our theta is 28 degrees. And the radius of the circle is 5 centimeters. And for you to have a sector, you have 2 radii. So this is also 5 centimeters. So even if it's not indicated, because it's a sector, they are equal. So we want to find this length. What is this fraction of the circumference of the entire circle? The formula again is theta over 360 times 2 pi r. And theta is 28 degrees over 360 times 2 times pi times 5 centimeters. I'll give you a few seconds to input that into your calculator. 28 divided by 360. Yes, you've done that. Multiply that by 2 pi. And then multiply that by 5 centimeters. And you would have 2.44 centimeters. So that's approximately 2.4. So that means that the length of this arc from this point to this point is 2.4 centimeters. That's what it means, because that's the arc length. So next, we want to find the sector area, or the area of the sector, this entire inner part, the entire sector, the chunk. So assuming that's a part of a piece of pizza, yes, we're finding the area. So the area sector, theta, 28, over 360 times pi r squared. So put that in your calculator. Theta is 28 degrees, divided by 360 degrees. I hope you are putting it in your calculator. Then multiply by pi, and multiply by radius squared. Our radius is 5. So it's 28 degrees over 360 times pi times 5 times 5. And that will give us 6.1 centimeter squared. Take note of the units. Because it's area, it's in squared units. And arc length is a linear measure, so it's in centimeters. And then the third part is to find the perimeter of the sector. What does that mean? Perimeter is the distance around a shape. So that means this radius plus the arc length and plus that radius. That will give us the perimeter of the sector. So, perimeter of the sector will be equal to 5 centimeters plus 5 centimeters plus the arc length, which is equal to 2.4 centimeters to 1 decimal place. So 5 plus 5 is 10. 10 plus 2.5. 5 plus 5 is 10. 10 plus 2.4 centimeters would give us 12.4 centimeters. Perimeter is also a linear measure, so is in centimeters. Very interesting. You can work out some more from Brilliant Maths Module 4. We want to look at another example, and it says the diameter of a circle is 60 centimeters. Find the angle which an arc of length 31.4 centimeters subtends at the center. So let's sketch this information. The diameter of the circle is 60 centimeters. That means the radius is 30 centimeters. So that's 30 centimeters, and that's also 30 centimeters. Because if you have a sector, then you have 2 radii. The angle which the arc of length 31.4. So that's the arc. And that arc is equal to 31.4 centimeters. So we want to find theta. This is exactly the question that we're supposed to solve. So, what's the formula for arc length? Arc length is equal to theta over 360. Theta over 360 times 2 pi r. But this time we have the arc length, which is 31.4. So 31.4 is equal to theta over 360 times 2 times pi times r is 30. So we need to make theta the subject, because that's what we're supposed to find. So to find theta, we'll multiply 31.4 by 360. And then we divide that product by 2 times pi times 30. Two times 3.142, which is pi, times 30. So what will be the value of theta? Put that into your calculator. 31.4 times 360 divided by 2 times 3.142, or pi, times 30. And what do you have? Theta is equal to 59.9 degrees, or 96, which is approximately 60 degrees. So the angle that is subtended at the center is 60 degrees. We can also generate a formula for finding theta from the main formula. Arc length is theta over 360 times 2 pi r. So to find theta, formula for theta will be arc length. The arc length is called L in most books, or most textbooks. So arc length times 360 over 2 pi r. So you can use this as a formula and solve without having to go through the steps. But I had to go through the steps so that you understand. But this is a direct formula for finding theta when you are given the arc length. For more examples, get a copy of Brilliant Maths Module 4. You will find it very useful. Next, we want to look at the chord of a circle. What is the chord of a circle? If you have a circle and you have a line, a straight line that passes from one part of the circumference to another, it is called a chord. As long as it's not passing through the center of the circle. Because if it passes through the center, then that would be a diameter. So that's a chord. This is also another chord. All right? The part enclosed between the chord and the circumference of the circle is called a segment. So you have the minor segment, which is a smaller part, and then a major segment for this chord. If you are looking at this chord, then this part will be the minor segment, and the rest of it will be the major segment. So please take note of that. So if you have a chord, like we have chord AB here, and O is the center of this circle. So you have a line from the center to the chord. That line is a perpendicular bisector. That line bisects the angle at the center, the angle at O, and also bisects the chord. So OM is a perpendicular bisector. It divides that angle into 2 and also divides the line AB in half. Let's look at the first example. It says XY is a chord of length 12 centimeters from one part of the circumference to the other, but not through the center. The circle has a radius of 10 centimeters. So that's a radius, and this is another radius. So this is also 10 centimeters. It says calculate angle XOY. So we want to calculate the angle at the center, popularly called theta. So where do you start? We can then begin to look at the properties of triangles, Pythagoras theorem. You need to remember everything you have learned about triangles and circles. If this length is 12 centimeters, and we have agreed that OM is a bisector, so we have a right angle triangle there. So that means that triangle OMY is a right angle triangle. If we agree on that, then the angle here, let's call it theta, or A. I'd rather call it A. Angle A can be found using SOHCAHTOA, because sine A is equal to opposite 6 centimeters over hypotenuse. You should remember that. The sine of angle A is equal to the line opposite angle A, which is 6 centimeters, over the hypotenuse, which is 10. So we can call sine A theta so that it's familiar. So theta then will be equal to the sine inverse of 6 over 10. So put that in your calculator and you will get 36.87 degrees. Put it in. So theta is equal to 36.87 degrees. Theta is an angle. But remember that in this case, our theta is our A. So the total angle at the center there will be 36.87 times 2. Try that out. So if we call this angle theta, so we have theta and theta, so that the angle at the center is actually 2 theta. So 2 theta is equal to 36.87 degrees times 2, which will give us 73.74 degrees. Approximately 73.7. So we have been able to calculate angle XOY. That's our 2 theta. We'd like to continue this question. So like I said, I want us to continue this question. Let's add something else to it. We could be asked to find the area of the minor segment or the major segment. So let's find the area of the minor segment. That's this portion. All right? So area of minor segment. How can we find that area? It will be the area of the minor sector. Remember that this is a sector. The sector is a triangle and the segment. So we'll find the area of the minor sector and then find the area of the triangle and then find the difference. Subtract the area of the triangle from the area of the minor sector and you'll get the area of the minor segment. That's very interesting. So let's go. Area of minor segment is equal to area of minor sector minus area of triangle XOY. I'd rather call it like that, triangle XOY. All right. So the area of the minor sector will be this entire portion. And what's the formula for the area of a sector? It's theta over 360 times pi r squared. So area of minor sector minus area of triangle XOY. XOY. Because we have two sides and an included angle, that's our 2 theta, which is 73.74 degrees, we'll use half AB sine C, or better put, half 10 times 10 sine 73.74. I'm just using general formulas here. So this is equal to theta is 73.74 over 360 times pi times r squared times pi times 10 squared minus half. Our AB is 10 times 10, so that is 10 squared. And then sine C, sine 73.74. All right, so here, I'd like you to put that into your calculator. So the area of the minor sector is 64.32. 64.32 centimeters squared minus the area of the triangle is 48.0. That's 48 centimeter squared. So what that means is the entire sector has an area of 64.32 centimeters squared. But the triangle, the one in blue, has an area of 48 centimeters. So to find the area of the segment, we subtract the area of the triangle from the area of the sector. So let's do this subtraction. And that would give us 64.32 minus 48 centimeters squared will give us 16.32 centimeters. Look at that. So the area of the minor segment is equal to 16.32 centimeters squared. It might take a little bit of time, but do practice. And you can get lots of examples and practice from Brilliant Maths Module 4. Yes, now the lesson is over. I hope you enjoyed it. Did you see those circles? Do you know how to find the area of a circle now? Semicircles, quadrants, or the quarter of a circle, circumference, and everything about circles, arc length, sectors, and so on. For more of these, subscribe to brilliantmaths.com. There are lots and lots of resources there for you. And always, always remember that maths is fun and easy, and you can do it. My name is Ngozi Orewogene. See you again.